today we're gonna talk a little bit more about sequences. So maybe I'm just gonna do a few more examples and see what's going on with sequences. So I'm just gonna do a few more examples on sequences, such as, I don't know, showing that some sequences converge. For example, the limit as n goes to infinity of the natural log of n divided by n. You can treat this sequence as if it was a function, and then you use L'Hopital's rule and say this is the same as the limit as n approaches infinity of 1 over n divided by 1, and therefore this limit is equals to 0. Other examples would be, I don't know, let's take a look at maybe something like, what is the limit as n approaches infinity of something like the nth root of n squared? Well, this is the same as the limit as n approaches infinity of n raised to the 1/2 power and then raised to the n power, like this, and this is the same as the limit as n approaches infinity of n to the 1 over n squared, and this is just equals to 1 squared equals to 1, because the limit of n raised to the 1 over n is equals to 1. There is this formula that says to find the limit as n approaches infinity of something like n minus 2 raised to the n power divided by n raised to the n power. You can write this as the limit as n approaches infinity of 1 plus minus 2 over n raised to the n power, and then there's a formula that says that the limit of this is equals e to the minus 2, because this is 1 plus x over n, the whole quantity raised to the n power, and this limit is supposed to be e to the x. Anyway, there are other sequences that are called recursive definitions. And these recursive definitions also lead to sequences. And basically, a recursive definition, you have like an initial value and then a rule that is called the recursive formula for calculating any other terms other than the previous or from the previous ones. So, for example, this a recursive relation with initial condition a1 equals 1 and a sub n equals to a sub n minus 1 plus 1 defines the sequence of positive integers. Let's find out. A1 is 1, a2 from the recursive formula is a1 plus 1, but a1 is 1, so 1 plus 1 is equals to 2. A3 is a2 plus 1, but a2 is 2, and then you add 1 to that, and then you get 3. A4 is equals to a3 plus 1, but a3 is 3, so 3 plus 1 is equals to 4, and as you can see, that recursive relation gives rise to this sequence, which is the sequence of positive integers 1, 2, 3, 4, blah blah blah, and blah blah blah. Let's do another one. This relation that says the statement a1 equals 1 and a sub n equals n times a sub n minus 1 for n bigger than 1. So basically you start with the initial condition, and then after that you plug in n for the recursive relation, so n equals to 2 because it's supposed to be for n bigger than 1. And this is 2 times a1. Well, this is 2 times 1, which is 2. A sub 3 is 3 times a2, but a2 is 2, so this is 3 times 2, which is 6. A sub 4 is equals to 4 times a sub 3, which is 4 times 6, which is 24. And this guy right here gives rise to this sequence n factorial. Remember, a1 would be 1 factorial, which is 1. A2 would be 2 factorial, which is 2 times 1, which is 2. A3 is 3 factorial, which is 3 times 1 times 2 times 1, which is 6, and so on and so forth. And here's an interesting recursive relation that goes like this. If you have the statements a1 equals 1 and a2 equals to 1, so two initial conditions, there could be more than one initial condition. And then we have this recursive relation a sub a plus 1 equals to a sub n plus a sub n minus 1. Then we have a sub 1 is 1, a sub 2 is 1, and then a sub 3 would be a sub 2 plus a sub 1. So it would be 1 plus 1, which is equals to 2. A sub 4 would be a sub 3 plus a sub 2, which would be 2 plus 1, which is equals to 3. A sub 5 would be a sub 4 plus a sub 3. A sub 4 is 3 and a sub 3 is 2, so adding those two things you get 5. A sub 5 is, a sub 6 is equals to a sub 5 plus a sub 4. A sub 5 is 5 and then plus 3, so this is 8. And this is the sequence of Fibonacci numbers. Which are, the first number is 1, the second number is 1, and then from that basically you get 2 by adding these 2, and then you get 3 by adding 2 and 1, and then you get 5 by adding 2 and 3, and then you get a by adding 3 and 5, and so on and so forth. These are the Fibonacci numbers. These Fibonacci numbers come in a lot of things. Some flowers, the number of petals on a flower, I think, is a Fibonacci number, and pine cones, pineapples, all those things have Fibonacci numbers. Okay, I think that's it for today. Thank you very much. Bye bye.